So we talk about the what are the key points of what? Key points of stainless steel. Okay. So corrosion resistance that we have discussed. This is the main component, and due to what are the responsible element, which is the chromium. Okay. So excellent resistance to the rust, oxidations, and staining due to the chromium content. So chromium is the main responsible. So whenever you are being asked what element are responsible, okay, to not having rusting in the stainless steel, then you could say that it is a chromium. And how much percentage? Which is the 10.5%, as you can see here. This is right. 10.5%. Okay. So, uh, so these are the component. Now we talk about the mechanical strength. Okay. So high tensile and yield strength. Tensile strength means if you can apply the load in a pulling nature. Okay, pulling nature, not a pushing nature. I mean, two kind of the force that we could apply over the body. It's either the pushing nature or the pulling nature. If you are having the pulling nature, that is known as tensile. Okay, so higher tensile means you can pull a body, or you can apply the load in a tensile nature, as long as it is. So it has a very high tensile nature. Means you can apply a tensile load up to a certain limit, which is feasible, right? Yield strength means before that it will not get failed. Okay, so that is the, I mean, the how much amount of load that you could apply, okay, before it get failed. Okay, so good toughness and good ductility. Ductility means how much you can stretch. And obvious, if something, if some any material which are having higher tensile strength, it means they are having the high ductility. Okay, so they are basically uh, you know having a linear relation. If the tensile strength is high, it means ductility will be high, because the ductility comes through the tensile nature. When you are applied the load in a tensile way, or tensile, yeah, in a tension, right? So it will basically, if they can resist, then you can have the more tensile strength. It means they will stretch long and along. I mean, they can stretch more and more. It means if they are stretching the more before breaking, it means they are basically ductile. Okay, so ductility and tensile are coming together. Okay, and if we talk about the toughness is basically the how much the resist, strain energy a body can store in itself. I have already know. I mean, energy will, if any material that is going to store more and more energy, but up to certain limit, if the limit has increased, they will break down. So storing energy in anywhere is has a limitations. We cannot stored anything beyond that limitations. So if you are incorporating more and more, then it will. So strain energy, how it comes when we are applying the load. Okay, so basically load is going to be converted into, I mean, your energy is being transformed into strain energy. Okay, and that stored energy, strain energy is basically stored inside the material, and that the capacity of storing strain energy inside the material before break is known as toughness. Okay, so they have the good toughness, means we can apply the more and more load before it breaks. We talk about thermal resistance. We have already made, they retain the strength and the resistor scaling at a elevated temperature. I mean, scaling means they are getting eroded. They are getting a lot of other chemical reactions over their surface, and they are basically being not having shining, or they are basically a rough surface. Okay, which is not desirable. Okay, so that is being resisted at a very high temperatures. So suitable for the both cryogenic and a high temperature applications. So cryogenic, as you know, that means the our space aircraft, they are using the cryogenic engines. They are having more and more high temperatures, and that temperature is must be resist by their walls and the equipment that has been made to resist that much of heat. Okay, so aesthetic appearance. This is just about, I mean, how they look. So it's smooth, as you can see. Okay, polished surface finish. We all know, I mean, whatever the, if you have a, mm, imagination of about your railings and your stainless steel products in your home appliances, then you can think about how they are having smoothness, they are looking so much shining. These all are, and if you talk about the surface finish, they all are having the good, you know in appearance. Okay, often used for the decorative purpose. I mean, it is being used for the decoration as well, sometimes to make the views are better. Okay, so non-magnetic or synthetic grade means, I mean, they are not having the magnetic natures per se. Okay, so authentic stainless steels, example of these are the steel, these are the steels names: 304, 316, and different, all 210. Okay, so different steels of their name have been written with the numbering. Okay, so these are the numbers, are generally non-magnetic. So some are magnetic and some are non-magnetic. Whatever the steel that we are talking about in our home appliances, they all are of non-magnetic. Okay, ease of fabrications. Okay, so if we talk about the fabrication, how they are being made, and how they are being basically synthesized, that is very easy. We can have the very less process, and with that not difficulties are there for formation of these kind of stainless steel, easily welded, machine formed. Okay, work hardening graded like the 304 improved the hard during the process. Okay, so these are the I mean, these things already have been discussed. If you talk about the welding, this is very easy process. Machining, that we have already discussed what is the machining. Okay, and formed means, I mean, if you are having to melt the material, and then you are basically forming in a different shapes. Okay, so no, so that's the casting. If you're forming out, you are making material at a higher temperature, and then you uh, uh, you know uh, give the force to make a different shape, like a blacksmith, as they do in a iron. Okay, here we're talking about the stainless steel.